Dear students, welcome to Learning Management System, Department of Collegiate and Technical Education. Water Resource Engineering is the course title and the course code is 15CE52T. Here we are discussing Unit 4, Reservoirs and Dams, Session 25 of the 5th semester Civil Engineering course. Before starting with the session, we have a small recap of Session 24, where earthen dams and typical cross-section of different types of earthen dams will be discussed briefly. An earthen dam is a dam made up of earth or the soil. It resists the forces exerted upon it mainly due to the shear strength of the soil. The earth dams are usually built in wide valleys. They can be built on all types of the foundation. On the basis of method of construction, the earth dams are classified into roller fill earth dam, hydraulic fill earth dam. This roller filled earth dam is further classified into homogeneous earth dam, zone-dyed earth dam, and diaphragm earth dam. This is about the brief of the earth dam. Now coming to the typical cross-section of earth dam, it has upstream face and the downstream face. At the upstream face, the reservoir level is there, which is called reservoir water surface level, and the stone pitching is provided as a barrier which helps in resisting the waves of erosion of the soil. It's also called as slope protection of the dam. And the pervious shell is present both at the upstream face and the downstream face. There is impervious core which is present in the center portion of the other dam, and the transition filter is present. The horizontal drainage blanket is provided at the toe portion of the dam. Now coming to the session 25. After learning this session, the student will be able to explain the causes of failure of the earthen dam, that is mainly structural failures. The causes of failure of the dam, it's broadly characterized into three categories. One is hydraulic failures, seepage failures, third one is structural failures. This is a pictorial representation which shows the earthen dam where upstream face is there and the downstream face. Upstream face water is stored and the downstream face water flows from upstream face to the downstream face to the gravity. Now I am going to show you a small animated video which describes the cause of failure of the earthen dam. It's three types. There is hydraulic failure, seepage failure, and the structural failure.
Hey guys, welcome to Civil Mentor. Earth-filled dams are less rigid and more susceptible to failure. Like most of engineering structures, earth dams may fail due to various reasons, such as faulty design, improper construction, and poor maintenance practices, etc. Different causes of failure of earth-filled dams are explained in this video. Stay tuned. Before moving on, I would like you to subscribe us and press the bell icon so that you never miss an update. Causes of failure of earth-filled dams. Different causes of failure of earth-filled dams are as follows. 1. Hydraulic failures of earth-filled dams. 4 out of every 10 earthen dams have failed due to hydraulic failures. The hydraulic failure of an earthen dam arises due to any of the following causes. Erosion of upstream face. Erosion of downstream toe. Due to overtopping. Due to frost action. Due to formation of gullies. 2. Seepage failure of earth-filled dams. Seepage through earth and dam is casual, but it is considered as harmless when it is limited or controllable. If it is uncontrollable, or concentrated seepage, then there occurs problems such as piping and sloughing. 1 out of every 3 failed dam cases have seepage failures. Seepage failure arises due to piping through foundation, piping through dam body, sloughing of downstream toe. 3. Structural failure of earth-fill dams. Another cause for failure of earthen dams is structural failures. About 1/4 of earthen dams have failed due to structural failures. Structural failure arises due to sliding of foundation, sliding of embankment. That's all for today. See you in the next video. Thanks for watching this video. Please like and share. And don't forget to subscribe us.
Yes. Now, in this animated video, we were able to see what are the causes of hydraulic failure, what are the causes of seepage failure, and what are the causes of structural failure. Now, in the next slide, we will discuss in detail about the structural failures. Structural failures are caused mainly due to sliding of upstream and downstream. Earth dam ಅಲ್ಲಿ 2 ಪಾರ್ಟ್ಸ್ ಇದೆ, ಒಂದು ಅಪ್ಸ್ಟ್ರೀಮ್ ಫೇಸ್ ಇದೆ, ಒಂದು ಡೌನ್ಸ್ಟ್ರೀಮ್ ಫೇಸ್ ಇದೆ. ಸ್ಲೈಡಿಂಗ್ ಅಂದ್ರೆ ಜರುಗೋದ್ರಿಂದ ನಮ್ದು ಅಪ್ಸ್ಟ್ರೀಮ್ಸ್ ಮತ್ತೆ ಡೌನ್ಸ್ಟ್ರೀಮ್ ಸ್ಲೋಪ್ ಫೇಲ್ ಆಗ್ಬೋದು. ಯಾಕೆ ಜರುಗೋದು ಅಂದ್ರೆ ಅರ್ಥ ಏನು ಅಂದ್ರೆ ಡ್ಯೂ ಟು ದ force exerted by the water on the upstream face of the dam. If it is more than the resisting force of the dam, then the sliding will be occurring. That is the structural failure. Now we'll discuss in brief about the structural failures. The first one is sliding of upstream and downstream flow. Second one is spontaneous liquefaction or liquefaction slide. Third one is damage caused by the burrowing animals. Fourth one, damage caused by water soluble materials. Next, damage caused by earthquake. Last, slope protection failure. Now first, we'll start with the sliding of upstream and downstream slopes. Yes, sliding of upstream and downstream slopes. It occurs when the forces tending to cause sliding of the soil mass becomes greater than the forces resisting the sliding. There are some of the causes on which the sliding of upstream and downstream depends. Those are given below. That is, first one is sliding of upstream slope due to sudden drawdown. Sliding of downstream slope during steady seepage of the water in the downstream side. Sliding of upstream or downstream slope or both during construction. Now this is a pictorial representation which shows the sliding of upstream slope during sudden drawdown. In this pictorial representation, we have an initial water reservoir level where, due to the excess pressure exerted by the water force, a rapid lower reservoir level takes place. That is nothing but the soil which is present in the upstream side, due to suddenly, rapidly, it flows down towards the base of the earth dam. Yes, this is about sliding of upstream slope due to sudden drawdown. Now, the sliding of downstream slope during steady seepage of the water. Yes, due to capillary action and the holes present, small holes or the gaps present or the voids present in the earthen dam, the water starts seepaging out from upstream side to the downstream slope. This is the pictorial representation which represents the steady seepage in the downstream portion of the earthen dam. This is two animated videos are there which shows the how the CPS takes place and how it gets multiplied, how it's get wider, and how does the other dam fails due to this seepage from upstream side to the downstream side. This is the video.
One of the most serious dam safety concerns is the stability of the earthen embankment. Unsafe conditions could lead to a major slide that threatens the safety of the dam. A key factor to stability is the location of the phreatic line, or the fully saturated zone of the soils within the embankment. In safe dams, this level is well confined below the surface. Since soils that are fully saturated are not as strong, a higher phreatic line can reduce the ability of the embankment to resist sliding. This is often noted by seepage exiting on the downstream face of the dam. Weak or poorly compacted soils can increase both seepage and the phreatic level, as well as weaken the embankment, contributing to a sliding failure of the dam. Properly designed dams often include an internal drainage system, such as a sand chimney and blanket drain. They serve as a filter to keep seepage from moving any soil, as well as allowing seepage to be removed in a controlled fashion. This lowers the phreatic line and improves the stability of the embankment. For existing dams with a high phreatic line, two alternatives can improve the dam's stability. One is to add a drain near the toe to both filter the seepage and lower the phreatic line through a controlled release of the seepage. The second is to add a berm for added resistance and improved stability of the embankment. This does not lower the phreatic line, but improves the dam's stability by adding weight to prevent slides in the embankment.
Yes.
Most all dams experience seepage to one degree or another. While the dam experiencing seepage may appear in sound condition, there may be damage occurring to the internal structure of the dam. If seepage flow rates appear to be increasing and the flow is not clear and is carrying material, internal erosion or piping is likely occurring. Piping is an erosion process that occurs inside the dam whenever the seepage flow starts eroding embankment materials out of and away from the dam. This starts at the downstream slope or toe and moves rapidly upstream to the impoundment. This process will tend to accelerate as the expanding larger opening or pipe allows for increased seepage flows. If left unattended, the seepage flow and progressive internal erosion will soon get out of control. When the internal pipe or void becomes large enough, the embankment structure above it will collapse. This will result in a failure of the dam's embankment and a potentially catastrophic release of the stored water, which may cause serious property damage and loss of life.
Yes, these are two videos which is showing the downstream failure due to seepage of the water. This is the next slide where spontaneous liquefaction or liquefaction slide occurs. Yes, it occurs when the saturated soil mass moves under gravity as if it was a very heavy viscous fluid. It occurs in the foundation of an earth dam if the foundation consists of fine sand and silt or some types of clays. These spontaneous liquefaction are also caused when a large part of the weight of the overlying soil mass is carried momentarily by the pore water of the saturated soil. Next. This is a pictorial representation which shows the spontaneous liquefaction where the saturated soil mass is present on the upstream side. When it gets mixed with the water, there is a generation of liquid from the solid soil mass takes place and the ದ್ರವವಾಗಿಸುವುದು. Hence, the spontaneous liquefaction takes place and it slides towards the downstream portion. This is the portion where it slides from where the saturated soil mass is there. After when it gets mixed with the water, it gets saturated and there is a liquefaction of this soil takes place. The liquefaction slides takes place. Now, yeah, in this concept, we will discuss with the damage caused by burrowing animals. The burrowing animals dig holes in earth dams to make their homes through which water makes its passage from the upstream side to the downstream side. The burrowing animals may cause failure of the earthen dam only to a small extent. Whereas burrowing animals which cause damage to the earth dam are here are muskrats, ground squirrels, snakes, beavers, eels, crawfish, mice, woodchucks, and rats. These are some of the burrowing animals which may cause failure to the earth dam. This is a pictorial representation which shows the damage to the earth dam by the burrowing animals. Where in the upstream phase, water level is present, a muskrat burrow is digging its home in the upstream phase of the earthen dam. There is a phreatic line. Phreatic line means it is the top of the flowing of the saturated soil mass below which seepage takes place. This is the phreatic surface. Now the muskrat starts digging its hole from the upstream side. There is a ground hog burrow, which is an animal. It starts its home digging the hole from the downstream portion of the dam, and hence the earth dam becomes big and there is a damage caused to the earthen dam. Now, damage caused by water soluble materials. The soil mass of the dam may also contain water soluble materials. The drainage of natural deposits, either from the abutments or from the foundation of the dam, may result in creating cavities and flow channels which may cause excessive settlement in the dam. Now, no serious damage may be caused to the dam only if small quantities of water soluble materials are present in the soil mass of the earth dam. Some of the water soluble materials which cause damage to the earthen dams are gypsum and iron oxide. Damage caused to earthen dam due to earthquake. First one, longitudinal cracks are developed at the top of the dam, at the crest portion of the dam, and hence due to this liquefaction of loose and saturated soil mass in the lower portion of the dam takes place. Due to this, settlement of the crust of the dam and reducing the freeboard and increasing the possibility of overtopping of the earth dam takes place. And cracking of the central core wall which leads to the leakage and piping failure of the earth dam. This is a pictorial representation which shows the failure of the dam. The whole earthen dam is split into two pieces. Slope protection failure. Slopes are generally protected by riprap, either hand-picked or dumped, over a layer of gravel or filter blanket. During heavy storm On the upstream side, the waves on the surface of the reservoir rapidly starts beating against the slope just above the reservoir level. This action of waves rapidly beating the upstream face of the dam has two effects. One, the waves produced washes away the filter layer, settling the riprap layer and exposing the embankment to the wave erosion. Second one is, if the riprap size is not heavy, it may be washed out of the layer by hydraulic forces generated by the waves. Now, this is a small pictorial representation which shows the riprap layer, which is either made up of irregular shape, which is of filled with the irregular shaped rubble stones. The gravel layer is placed, and you may see the beach eroded in the slope due to the failure. Reservoir layer is there, and you will still more have the cross-sectional portion of the slope protection in the next slide. That is, here upstream portion is there, top embankment is there, and in the pictorial representation you will see the riprap layer which is filled with the rocks or the rubble stones, and below the rock or the riprap layer there is a gravel bedding is provided. For this gravel bedding a filter media is provided. Filter media is made of either sand or filter fabrics. This is a pictorial representation of the slope protection. Now we'll start with the multiple choice question. It is first one. The causes of failure of earth dams are listed below. Choose the correct one. Given are hydraulic failure, seepage failures, structural failures, all of the above. You have seen in the first slide what are the causes of failure. The causes of failure are hydraulic failures, seepage failures, and structural failure. These are the three main causes of failure of the earth dams. That is, answer is D. All of the above. Answer is D. Second one. The structural failure includes the failure of earth dams due to given are hydraulic failures, seepage failures, flooding of upstream and downstream slope, none of the above. There are various causes of structural failures. Among them, given one is here is sliding of upstream and downstream slope. Yeah, that is the correct answer. Structural slope failure is answer is C, which is sliding of upstream and downstream slope. Third one, sliding of upstream and downstream are caused due to given are spillway of water, inspection galleries failure, sliding of upstream of slope during sudden drawdown, none of the above. The sliding of upstream and downstream are caused due to this is the one of the cause which is sliding of upstream of slope during sudden drawdown. There are two other causes also. That here is answer is C, which is the correct answer. Now fourth one. The flow or liquefaction slides in the foundation as well as in the lower portion of the earth dam has caused about -% of failure of the earth dam in the past. Given are 4, 6, 7%, 3%, correct answer is 3%. In the past, we have observed that only 3% of the earth dam has failed due to liquefaction slides. Answer is D, that is 3%. Fifth one, burrowing animal which may cause failure of earth dam is given here is bat, dog, muskrat, all of the above. Given are the animals which may cause failure to the earth dam by burrowing. In that, muskrat is the animal which cause failure to the earth dam. So answer is C. Next one, the water soluble material which may cause damage to earth dam is given here is limestone, shale, iron oxide, and magnesium oxide. In this session, we will discuss the water soluble material which cause failure to the dam is Iron oxide. Yes, answer is C. 7. The damages which may be caused to the earthen dam due to earthquake is various types of damages are here given here. That is shear failure at the base of the dam, longitudinal cross-section at the top of the dam, liquefaction of loose and saturated soil mass, all of the above. As you have seen in the damage caused due to earthen dam, which was the damage caused due to earthen dam for the earthen dam failure is longitudinal cracks at the top of the dam. That is answer is B. In slope protection failure, if the average size of the rock comprising riprap is not heavy, it may be washed out. Which is washed out? The riprap may be washed out of the layer by the dash forces generated by the waves. Waves will be generating a force. What is the force? What is the force that is generated by the wave? As listed here, hydraulic force, whether it is uplift force, whether it is gravity force, all of the above. That's the given answer is. The answer is hydraulic forces. The water forces due to the water are the forces which are generated by the waves. So due to this force, the slope protection failure is caused. That's the answer is hydraulic failure. Hydraulic forces. 9. The slope of earth dams are generally protected by dash over a layer of gravel or filter blanket. What are the given slopes are? What the given material is? Either concrete, it is either wood, it may be either riprap or all of the above. Yes, it is a riprap layer which is provided, which is comprised of either rocks or rubble stones. That is riprap layer. Answer is C. Thank you. Bye now.